up topics, issues, or opportunities as we go along. We want this to be highly interactive, and maybe it's time for the marine participants to come forward and ask these experts what is on their mind. Anyway, we also decided to bring our mascot, Kira, because we heard about beavers and penguins and all kinds of, and Kira is quite a part of our setup. She's the Marsec XL mascot, usually around all the time. She's been a bit lonely in the past couple of days. All right, so with that, I hand over to Jørgen for a start.
All right, good morning, everyone. I think rule one is don't have a party before the last day of the conference, right? This is a rather small crowd this morning. Second, I have a disappointment. I will not announce turn-by-turn navigation systems for super yachts. We stepped away from that. We'll not make that available. So what I want, Google.com. Okay, let's get beyond that one. What I wanted to do is just as a teaser to get us going, right? Present some ideas or my views on what I think testing in the cloud or for the cloud looks like, and what some of the differences are compared to regular off-the-shelf software development. I don't know how much time you want me to do. 10 minutes, 15 minutes?
That's fine.
Okay. So I'll leave some out and get some. So rule number one, it has to be fast, right? I think that's the biggest difference, pretty obvious, between development for the web and the off-the-shelf. In my previous life, my cycle times were, when we were really fast, 9 months to get a new release out on CDs, in the box, on the shelf, right? And the biggest problem we had was, other than always being late, to have a really hard time to support and service that software that everyone had installed, which I think is the second big difference, that we don't, if you really develop in and for the cloud, you don't have installs anywhere. You don't have, PCs or Unix boxes or whatever hardware that are not under your control that run your software, right? We are able to make any change we want at any point in time we want, as long as we do it in a way that the system doesn't crash and everyone is still able to use the service. So the challenge that we are seeing now, or we are looking at now, is not so much, how fast can I do my release, but if you go beyond the pure operational process of, okay, what does it take? You have a piece of code to get it out there. Another big piece we are focusing on is what does it take to get from your idea you have in your head to having it out in the web and see what happens, right? Yesterday, I forgot who, someone mentioned, innovation isn't worth anything until it's out there and proven and used. Was it you? Sorry. I think that perfect comment, right? It's a big step, and just an idea is very cheap and can be great, but it will only be great if someone is up there who can turn it into reality. Some of the things we'll talk about in the next minutes. Okay. So we all know that software engineering and software testing came from this whole parallel to how cars are built and how manufacturing happens. It came from the QA world, and we're clearly away from that. And the biggest changes, I think, is that the repeatability aspect that was in that world is still there. We want repeatability, but I think the software development process has adapted to that quite a bit. It's not so much that we release in waves, but that we make available whatever is ready to make available in much smaller pieces. You don't get these humongous new versions that have 75 million new features. You get it piecemeal, but much, much faster in some of our products every week. Our focus was mainly the last line there, that we want to get the developer who is actually creating the code to get in the role of being the tester at the same time. Right? Separating of these roles leads to all kinds of troubles that people who are in that field know very well. Help? Can you move, please?
Yeah, I just wanted to stress that point that tester was the developer. It's one of the also the key features I think in open source technology in general is that the best developers are also the people who are the end users of the software that they're actually developing as well. So not only do you have a very tight feedback loop from the end users that you're actually pushing the software to, but actually when you have developers actually also using that software, they have their own very tight feedback loop as well. And I think that and that Google's appreciation of that I think is key and crucial.
So one of the things, we'll just go wild and as the things come up here. One of the things we do to implement that idea, right, or to support that, is that we have a process that we call dog fooding our software. So eat your own dog food is the American phrase that's behind that idea. So for example, Google Calendar, which I have been responsible in validating for a while, we have a hierarchy of builds that people have to use. One of the things we introduced is that every day, all the engineers, which are about 30 people, have to use that nightly build, right? And so if they change anything on Tuesday, Wednesday morning they have to deal with that in whatever comes out, right? After 4 days, that release will move out to Google internally automatically. So they can't really prevent this, right? They can only make sure it's as good as it can possibly be. That also includes the realization that some of the problems that will come, they will not be able to find themselves, right? There is load aspects, there is stress aspects. If 20 people use the system, it's a very different behavior of the system than 20,000, obviously, right? And then if you spin this forward, that's exactly what we do, right? So you start with 20, you get again to a few thousand, 20,000, all the Googlers, which is the dog food system. Then we have a concept for some of the products where we actually make money with the advertising features of the system. We have what we call trusted testers, which are outside of Google, but partners and trusted enough to, not cause a disaster if something happens. So they will give it a spin for a few days, and then we release it out, right? For those things that go to the web, like search or maps, we have a rollout in the web that goes incrementally up. Right, so when I mentioned yesterday, YouTube, for example, has a one-day release cycle, release schedule, say, right? So we begin in the morning, we go through the steps. Shortly after noon, we start pushing out live to 1% of the servers. So we will see it across the world, some of the servers with a new code base, and see what happens, right? So at that point, we feel pretty confident that okay, it's functionally okay. We know the low-end usage behavior, and then we start loading it up. And then every hour we add some more, and usually by 6, 7 at night we are at 60%, and we know okay, right? We can let go it overnight, right? And that gives that same. It's a way, an attempt to give that idea a chance, right? To say, okay, let's use it at any time, right? And you cannot put things in that say, let me put the code in the base. It's not quite ready, but who cares, right? A lot of people care, and we make sure they do care and that you are not able to do that.
Right, and compare that to traditional software development where if it's broken, so what? As a developer, it doesn't hurt me at all if the software that I push and develop, it hurts the end user. Whereas when you make the end user the developer, then if a change that I've made causes something to break, it affects me personally. And so you've got that incentive, of course, to obviously fix it and get that, quick turnaround time.
All right, let me see what other things. This is also part of maybe some part of the idea of what I just expressed. Before we go to the phased rollout in growing the group of people who use it to verify, we start with the idea that you should always be able to put the piece of code you're writing into the large system and see the effect, right? So we call this continuous integration. At any point in time, you can submit the code and see how the whole system looks like after you did this. It's very different from saying, okay, next Wednesday we have a build where all the pieces come together, get ready. That is a very typical scenario, although it sounds funny. This is, for those of you who work in larger groups in development outside of Agile, it's very usual to have that kind of setup. Wednesday night we integrate 200 tracks, features, right? And no one knows what feature 1 will do when it runs together with feature 75 in the system, right? So we want to get away from that. It also leads, if you have this continuous and frequent frequent submit options, and you know that the results will be fed back to you very quickly, right? It leads to the behavior of submitting only rather small code changes, which is a very good thing, right? If you know you can have only one shot in the week, you put everything you ever can think of in that track and submit it, because you fix it later. But if you know, I can do the same thing in 10 minutes down the road, right, or after lunch, then the temptation to do that is not there, and the need to do it is not there. You just go clean, right? And usually the tracks that you submit reflect actually the code you were changing, and that makes logical sense, which is very good if you go into code analysis, right? A lot of positive outcomes of this.
But behind all of this, is there a grand plan, bigger plan, 6 months?
Sure. I mean, yes, that hasn't changed, right? We're not saying we can deliver any piece of function in 10 minutes, right? That's not the claim. Some of those features take 1 quarter, some even take 2 quarters of a set of people to get completely done, right? But what you want to do is not have these 4 people going away in a dark room for 4 months and doing something that is completely cut off of what the rest of the group is doing to the code. So when they come back, they don't have the integration problem, right, and the remerge problem. They have to find a way to do those things in as small bits and pieces as possible and keep in sync with what the rest of the group is doing to the code base, right?
It almost forces a culture where everyone is sort of like marching, even if it's by small steps, in a common direction, rather than people, there's the phrase herding cats, where you've got, people, developers going this way, developers going that way, and then at some point in the future, trying to get them all together and create something which works. And that, obviously, doesn't work very, very well. It certainly isn't scalable, because obviously the more cats, the more you've got to herd them. It's also important too to remember that, especially the way that Google does it, is that it again, by not having a process where you say, oh, Wednesday we're going to release the code, and we're going to give it to someone else to test. Well, that just makes a break between the people who are developing the code, the people who are testing the code, the people who are using the code. By forcing that culture, you get away from that. Those problems of having large parts working together.
My insight is that on those scenarios, completely different. Because Google is, the user base connected to the web, but if they want, the code has to be made perfect for deployment, because you can't put a new capture something on a node that doesn't have an internet connection.
Mm-hmm. Well, once it's there, it's always going to be bugs in whatever there is. The idea is to have any change that you make never have a backward regression, to always fix something. It's true, you can't ship, especially in a super yacht, something which is only works halfway. Okay, you've got to have a list of requirements. These are things they have to do, and make sure that the first release of that software that is being shipped to the super yachts works. But then what you don't want to do is have releases which pile up a whole bunch of different bugs, and then 6 months from now we do another release. You want it to be a gradual process.
Yep.
Sorry, go ahead.
And this is where we are touching upon zero defect in operation, as we were talking about, as you mentioned, is it possible or not possible to write zero defect software? What does it really mean, zero defect?
It is impossible.
It will not.
It is impossible.
But if you take user scenarios into account, then you have zero defect in operation because it's for a specific usage, right?
I think it's impossible.
But it's not from the beginning. However, you must be able to quantify if you. There may be required in situations when you do.
There are bugs found in 10-year-old systems.
That's for sure.
Right? That have
But,
been in operation.
but we're not talking about bugs. We're talking about defects.
What's the difference?
Exactly.
Well,
I know, what's the difference? When you say you're not talking about bugs, but you're talking about defects. What's the difference between the
A defect is an operational condition that leads to a failure of a system.
That the software doesn't do what is expected, not intended or specified, let's say.
when I worked at NASA, there was this concept of no single points of failure, such that there was no failure scenario such that back then you would lose operation of the spacecraft or something like that. Now, of course, that did not mean that there weren't errors in the actual code or the circuit design or things like that, but that as far as we could determine from all the user
Test.
is this really needed? Am I talking out loud enough? But just okay. Okay, recording. Okay, so let me get back to where I was. Oh yeah. So the issue, of course, is that you can only determine how you would get to a single point of failure by having an exacting level of possible failure scenarios, and you will never capture all those possible failure scenarios. So there is always the possibility that something that you didn't come up with could cause an error, either possibly a failure that would cause something right. And that's the reason why you're continually, improving and things like that. So the problem is that, or the issue, or the challenge, as it were, is that it means that you've got to, of course, really, really understand your audience, really understand the scenario that you're looking for in the software. The more you understand the challenges involved with the maritime industry, super yachts, the challenges that super yachts, would impose on the software, the more you can come up with sort of like those failure scenarios. What would cause this to happen? What would cause that to happen? And you would get to a point where, with the software and the architecture that you have, every possible scenario that we can think of that would cause a single point of failure, a catastrophic, and not, catastrophic can mean anything from, the engines would turn off unexpectedly or something like that. Then you would be able to test for that, okay? But you would always be growing that list of possible failures. You would always be determining new defects that you would need to. So there is a point where you have to draw that line in the sand and say, this is when we release. But that line in the sand is always progressing because the software is always going to be used differently. There's always going to be different usage scenarios. And so you're going to get a lot more information back than, and that's the nice thing about, large communities being able to provide that feedback.
Yeah, I strongly support this, right? Do not assume you're done, right? Because that leads you down a path, I think, where you stop or you don't start thinking about solving that problem beyond that line that you drew in the sand, right? I would encourage you to think about how to, even in super yachts, find a way to update them while they're out there, right? Because you will not be, that line is a fallacy.
And it starts off because your design, because you think there's a stop point. Mentally, you're envisioning a system which is closed because there's no reason to continually upgrade it.
No.
You've got to start from the beginning knowing that it's open constantly because you're always going to want that feedback in there. So from the very beginning to the very end, you've got to maintain the idea that this is open because we want those enhancements, those fixes to always come back.
I think we're actually at almost a key point for the reason of usage of open source, because the massive usage you get improves the quality. And since we all have started to understand that it's mission impossible to have that closed, proprietary, ultimately tested system that will always work, we have to find another way. And one of the things I think the marine industry should think about is that we have massive usage of many software systems out there today, and why not harness all of that capability using COTS, using open source, so we avoid a lot of the trouble we're currently getting into. That's one of the reasons we posted MARSA, that's one of the reasons we have this conference, because we think it's time to use that resource and avoid all of these single point of failures, because it's very, very limited system, very complex, with far too many features and impossible to get zero defect.
So unfortunately, I haven't really looked at the spec. Is there a provision for remote upgrade? Yes. Okay. That, because I think that is the most important feature that Android brought to the market in the mobile world. Right? If you go back, I don't know, 5 years or so, right? The situation in mobile was that you buy a new phone. Right? Seriously. So go buy a new super yacht, right? Sorry, we got to buy it, right? And that landscape has completely changed. You know, you get those things without noticing, or you can set it up so you get the updates without noticing, and they're just there. The next morning you look at the thing again, and it has happened, right? So yeah, you have different constraints, and you may not be able to 24/7 be connected. Well, but if it's 1 hour per day that you're connected, that may be enough bandwidth to get the stuff out there, right?
And I think in this whole concept of incremental development and testing, the STEC testing lab is perfect, because we can test there before we deploy it on a super yacht. Exactly.
It's a pity that Brian from the US Navy is not here today, because I learned a lot from them when I was at the San Diego Naval Base, because they talked a lot about this idea of operational prototypes, and they said that it must be clear that instead you can wait for the ultimate solution, which we can agree will never occur. You can spend dollars, 18 months of validation, and then deploy a service 12 months too late. It's much better to bring apps into even the battleships, that you are aware that this is not, it's an operational prototype, but you get functionality and you can get feedback from users. So it's basically what you say. Right. They say that the guys in development and validation are far less effective than the operational people when it comes to validating the goodness of the service. And that has to be the same with mariners. I think in the super yacht business, for example, we interview a lot of captains. These captains are very often very interested in what they're actually doing. I think most captains are actually, they're proud of what they're doing, they're quite interactive, and they have a lot of time. So when the yacht is moving or the commercial ship is moving, they could have the possibility to actually, if they had some kind of interaction, like yacht book or something, they would post information about navigational hazards, observations that the map is not correct here, all kinds of things that would be helpful for others, but currently they have no such means. And that is a functionality we think we should provide very, very, very quickly, in the same, like in a Google-style fashion.
So what you mentioned on the topic of getting people's mind around dealing with something that we acknowledge is not ready, right? I mean, we have all the time, we just didn't acknowledge it. We have exactly the same problem with our engineers, right? One of the philosophy points that we try to push is don't wait until the feature is perfect to get it out there, right? Because even when you think it's perfect, it may not, because the users out there behave in very mysterious ways at times, right? And they love something that you didn't expect, and they hate something where you were convinced, oh, this is the thing, right? And so we don't, that's the hard lesson, I think. We don't create this software for ourselves. That's tough. It's a tough message to get through. So what we are pushing is to force everyone to really release the idea. So that doesn't mean it's allowed to be buggy or badly implemented or sloppily designed or any of this, right? But it is about the idea to get the core minimal piece that conveys the message out quickly and have that validated and supported or rejected, right? And we have, not sure you heard about Google Apps. It's a way to bring out individual small features in a way that is working. It's doing all the right things, but it's small in the sense that it's not fully integrated maybe, but we allow, it's a way to say, look, bring it out there. It's a way to get feedback. Do many people like this? Then it may be propagated into a product feature. If it doesn't get the pickup we all thought it would, then not, right? And some of those stay in labs. It's kind of a in-between for a while. Then we take it off and say, well, it wasn't just the right thing, and others make it in there. I don't know how to translate this in your world, right? The point was, it's the same with engineers, right? They want to be perfect.
In some ways, it's sort of like, creating software now isn't like building a house. And it's not usable until it's done. And then once it's done, you do little things to it, new painting, maybe new tile on the floors or something like that. But those are small, changes. If you want something different, you sell that house and you buy a new house. That's the old way of looking at software development. It's almost like, and I realize that many of you are very young, but it's almost like building a child, growing a child. A child will always grow. Every day it's changing, small incremental changes. And so the person that there is this year is going to be very, very different from the one that. So it's very, very small, gradual changes. And again, it's maintaining that concept that it's a process. It's not a product. It's a process.
And that's really why we think we have to get onto this service-oriented architecture and a cloud-based system, because basically you can then have a safe computing environment, so you don't lose specific functions. You can have even fail-safe or fault-tolerant systems for that, and then you can start to deploy various apps or services on a more experimental and growing basis. So that's what we want to do, because currently we have this problem that many of our clients and the owners say that I want to be on the cutting edge, but I don't want to be on the bleeding edge. Meaning my yacht is not going to be an experimental lab with cables hanging out, with software stuff that doesn't work. And we have to get away from that thinking and think about it in a different way, where we have a stable environment for the front ends, for the computing, for the storage, and then you can put things on it and experiment and so on, and the whole thing doesn't fall apart because of doing that. That's what we want to do.
The thing though with especially super yacht business is that quite often owners want to have something special and customized at the same time. So this is where we're touching, upon mass customization questions. how to go about it, still to give the feel of the owner of something very special and just the one-off feeling. However, how are we going to make sure that this is not this one-off system?
Right. And one-offs are historically incredibly difficult to maintain as things change and things like that. So again, having that open architecture where the customization doesn't directly impact the core functionality, that you can add it as a layer on top rather than it being a really deep entwined part of the architecture.
I liked your metaphor on the growing a child.
Mm-hmm.
Right? I don't have the deck here. I had a similar one used where I compare what we do from a testing point of view to a hospital. Right? If you go to the hospital, there is kind of a standard first order diagnosis on, okay, what's wrong? You're going to the heart surgery segment or in the intestine segment or whatever, right? And what I think we're lacking, I know in Google we are lacking, is a kind of standardized way to look at not the bits and pieces and the small features and on the unit test level. We are very good at that and we understand how that's done. What we're not good at is to look at the overall system and are able quickly to determine, okay, it's in that area, it's such and such a type of problem, the following should happen, and the following next level of detail should now be analyzed, right? And what are and that leads me back, it's not completely out there. It leads me back to a comment you make. Because then what we realized is, in order to do that, you need to prepare for it, right? You need to think about what type of signals do you want to be able to look at historically in the last hour, say. What happened? Store away those signals that allow you then, if something happened, to analyze, to think about, to go back and try to recreate, etc., etc. And that is something that is really hard to do, because there is also the point that you can't envision everything that might possibly happen. But back to the metaphor, right? If you go to the hospital, they are exactly in the same situation. They don't know what's really going on. Most of it is guesswork. Most of it is experience, meaning many of those cases had a positive effect if you did this, right? Doesn't necessarily mean you're one of them. We can hope, right? But at least there is a procedural way. You take these measures, you get those results, you follow up with those actions, and then loop through those in more and more detail. That is where I think we have to get better, and especially if you have these independent systems, these autonomous systems out there that you only have reduced access to, I think it becomes even more important to think through, not only to understand what the object did, so what engine failure you had and what signals there were out there, but kind of on the meta level. What did my software do in that moment, and why was that the wrong thing, or what should have, etc. Right? And I know we are far away from having a healthy story there. Right? All right. Do I need to find a new topic? Let's see. What else did I want to talk about? How are we in time?
You're halfway.
Halfway.
Should I say something about data?
Well, one of the things that we have thought a lot about in Marsec Excel is that there's so much data out there in wasted data, non-correlated data, not validated data, not even collected, sometimes in the weirdest places. To give you an example, for those of you that are not mariners, one concern for any captain or any boat driver is navigational hazards, and they are very different to on land, because the roads doesn't move that often on the maps and so on. Well, you actually can, with modern navigation systems, find the other roundabout and so on that is not on the map. But in sea life, this is a continuous updating thing. You can have sea marks that disappear. You can have shooting ranges for the military. You can have Maltese fireworks, start a Rolex Middle Sea race and so on. And it's puzzling to us that, so we have these navigational maps that we buy for very significant money, put it into a chart plotter, and sometimes they're pretty much out of date. So to give an example from here, I have on my Ray Marine system one map from the same provider. On my iPad I have a different map, and the one on the iPad actually has more information about seaplanes leaving and so on, because it's like newer. But you can't buy that one for the other thing, right? Then Then some people have come up with a brilliant idea on the web that you can of course input Google Earth on top of this, which gives you more information, but it's still not real time. Then we have the all famous Transport Malta and all of these authorities that put out a lot of good information called Notice to Mariners. So for example, tomorrow there's a notice to mariners about the start of the Rolex Middle Sea race. So between 8:30 and 3 o'clock, no vessels can enter the harbor, but you have to go to the web, and it's then way down there you find a PDF with a map that you have to compare to your paper chart to figure out where am I allowed to go or not. Now, when you talk to the captains and you talk to Transport Malta or other maritime authorities, they would love if they had an online system where they could put this straight onto the map to be displayed in the boats. And the captains would love to say, if we had a voting system like you have for certain things, that let's say 10 captains verify that this sea mark is not there, so there's a warning coming up. Simple. Can it be done? Of course it can be done. We're just missing the infrastructure and the backbone to do these things. And I'm urging the marine business to say, okay, let's stop thinking that we're so special. Let's use what the rest of the world has available and then try to build our specialities on top of it. And all of a sudden we'll have a much better service.
Right. I mean, you know, when you look at it, I mean, it would be almost like trying to say, I'm going to go and provide a weather map that is good last month. So what I have is last month's weather map. I'm using that today and trying to figure out what the weather is going to be like today. I mean, data is only as good as current as it is. You know, the older the data is, the more, you know, unreliable, the less useful it is to people. So, you know, as you say, I mean, you get the maps. They're good for at that point in time, but as we all know, you know, it changes. You know, things change. The weather changes. The currents change. You know, the ebb and flow of the tides change. You know, channel areas. So the depths might be a little bit lower, a little bit higher than what's on the maps at that particular time. So if you can constantly update that information. And have it be a collaborative, you know, system, especially a system that really requires almost no interaction from the captains themselves. The open architecture, the super yachts themselves will collate that data, update it, and send that back and forth. So the advantage to the marine industry is that now you're able to provide much better data to all the separate components that require that data. You make the captain's lives easier, but also it makes things easier for the propulsion system as well, for example, because now you can say, okay, well, I'm providing some information to the captain that he might be, you know, useful, you know, want to know, an easier course that would save on fuel or something like that. So, you know, and the cloud and having all that information available in the cloud would be, you know, extremely, changing, you know, to the entire industry, I think.
And I would agree, it has to be simple, right? Otherwise, if it's not simple, it takes time. If it takes time, it's probably, again, too late, right? One example that came to mind was the difference between live traffic information in larger cities or hotspots of where cops flash their lights randomly, which typically happen through radio stations, right? Call in and we'll broadcast this for you. And if you happen to listen at the right station at the right time, you knew the flash is ahead of you, right? Or how is the traffic, right? The usual thing was every half hour or 10 minutes updates in the radio, and you get your thing. What we did with Google Traffic, if you've heard of that, is to use the information that's already out there, which was for all signed-in phones, the IP location, right? The triangulated IP location. Just take that data and use that for something completely different, which was mapping it on the street and take condensity and speed of move to say, oh, there is a clock, right? There is a, what's it called? A congestion. Thank you, right? So they're sitting there. And if you look for the larger, higher populated cities, well, cities where more of those phones are switched on all the time. I think that's the constraint right now. You can see, you know, red, green, yellow blocks in the street that give you a pretty accurate, maybe within the minute or so, view of, okay, so basically what it says, there's a lot of IP points always at the same time for the last minutes, right? Well, that translated to congestion. You could map this one-to-one without zero effort right now, right? From if you get the IP from all those boats. What, 60 million? It's a lot of boats, right? So
it doesn't require the
60
person to say, I'm in a traffic
30 million,
press a
30
button
million.
or something like that. You know, it's automatic.
It's exactly, and that is the key point, right? As long as someone has to do something manually, it won't happen in time, right? But if you can use a signal that's already there and be clever about what you do and how you do the math around it. So on the car, I mean, your numbers are trivial, really tiny, right? If you look at the numbers of cars that are beeping up, or the phones beeping up their IP, and us, you know, sorting through these, your 30 million chips is nothing.
I mean, a good example would be depth finder ranges. I mean, that's something which is constantly being, you know, monitored by the captain. Why can't you use that to update data to the cloud? So that way you're getting a constant, you know, update of the actual, you know, depths of where things are.
Another parallel to this, I think, is what we did with Street View. I think it's exactly the same, but on dry versus wet, right? And with maybe more cars, I don't know. So the original thought was, well, the maps are not really good, right? So there is the roundabout and where it isn't, and there is an end of street where it isn't, and between reality and map. And so what we set out to do was we wanted to build the golden map, built by reality and not by the 75th copy of an old map that someone, you know, manually, oh, yeah, this is wrong, there's the street goes like this, right? Send out the cars, have them drive the streets, collect the GPS signals, and go from there. And then find, there was a lot of little tricky things in there, but basically is you want to draw the map where all these cars were going, right? And you could do exactly the same with the boats, right?
And here comes a big surprise to some people that are not in the super yacht business. Then we have all the equipment on board to do this. We have cameras, we have night vision cameras, we have very accurate, we have sonars, forward-looking, sideways-looking in some boats, we have depth sounders, we have radar signal. I mean, you don't have that in a car usually, at least not. So we have so much wasted data that it's just, sometimes it's not even logged, it's just there and doing nothing.
You don't have
So-
an open architecture to collate
Exactly.
all of that
So
data.
if we have this wonderful architecture and we can start collect and combine these data points, because basically I'm looking at my boat professor here. What he was teaching us by some, sorry.
I used to work for NASDAQ, and NASDAQ had a very large proprietary database, and of course Google does too. There's also the OpenStreetMap community, and many people fervently believe that street map data ought to be open to everybody. Let's put it in the context of the sea and this discussion. Would you see that kind of data being open sourced, or does it become proprietary data of some company?
that's what we would really like to do. I mean, and getting back to my point here that Jørgen Emanuelsson made to us is that when you're driving a boat, you shall always validate what you observe with one other source. So that's why you have a radar and a GPS and a depth sounder. And a good captain has sort of 4 sources. You have the radar, you have the GPS position, you have the depth sounder, and you have your eyes. And if one of these disagree, you slow down. And that's basically what we could do automatically.
But who's going to make that collection of data and the aggregation of the data open, as opposed to it's part of a commercial system and becomes the property of the data becomes the property.
That's where the open data comes in, and that's what we would like to do, because then you could share it with the whole population of vessels, and not only for your system or your boat. And so that's where so we have a lot of possibilities to cross-correlate data. So if the GPS isn't correct, you can say, okay, well, the depth sounder shows something else, or the radar shows something else. And if we could manage to collect this in an open architecture and then share it, so we have multiple vessels, this is almost too simple to be true.
A concept we have discussed between us while working on Mars is like this data could also be used to design better yachts for the future. But a typical problem is that the lead time from the design to final product of a super yacht is years. So the data of today may not be the data we need for 3 years down the line. So how can we go about that?
So one thing that came to mind on the topic of open. So you have these layers of problems that you have to deal with, and they are of a different nature, I think, right? So architecturally, I think let's assume you solve this, right? It's easy to, if it's even necessary and not yet included, to extend that architecture to say, okay, here's the ways and means, and here's what has to happen, and here's what's optional, and so you can try to help enforce this to happen. The next is, okay, you then agree on data formats and exchange formats and all, so that everything can talk to everything else. You agree that everyone agrees that the data that's exchanged will be stored and such type of usage with it, and so you're all fine on the legal part. Now I think comes the tough part that says, who's going to host this, right? So open doesn't mean free. Right? We had that yesterday too. Right? So there is a cost with this. So you have to generate the data, you want to store it, where do you put it? Who owns the machine? Who maintains the machine? Who pays the bill for the electricity? Blah, 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 right? The same then for the computational aspects. So you need quite a bit of CPU power to crunch through this and do the triangulation and whatever is behind this, right? It's not enormous, but you need a dedicated system that 24/7 will do this, because otherwise you're getting in these delay problems again, right? And I think that is maybe a community problem, right? To say, okay, so how do we support this idea with real stuff that runs 24/7 for the next years, and do we found a group that sponsors this financially? Do we found a host that,
At the risk of belaboring my point, and I'm not truly all that knowledgeable about the organization, but there is a large infrastructure for the people that are around that OpenStreetMap collection. And they sponsor local groups with people go out with GPS devices and map a particular neighborhood and upload all the data, and they've got tools to massage that data as it comes in. It's one thing to talk, and I don't know if there's an equivalent group that's forming around geographical data related to the seas, but that doesn't happen accidentally. There's got to be a group that cares enough about it that forms itself and starts laying the infrastructure. And so clearly you have enough on your plate already, but if this is a key part of the future vision, maybe that's the additional group that you start sponsoring, is the collection of open seas data and the tools that you will need to make that happen, and the encouragement of people to provide that data to you.
we truly appreciate these very valid comments, because we could see that the first step that has to be sorted is this common open reference architecture, because if we don't have that, it's almost going to be impossible to do these things now. We started to look at the validity of data, how to collect data, how to have common formats and so on, and we heard some very good talks about that yesterday, so we're progressing. Then we believe that it really depends on what service we're talking about, because there are different services possible around marine. We have one thing is marine safety, and we believe that in marine safety there are good organizations and good international fora where different countries could possibly, for marine safety, be willing to sponsor some hosting, etc. So it could be a network around that. Another topic that I think the European Commission knows about very much, and different countries in the Union and even the US, is marine pollution. And the tracking of marine pollution and the tracking of SOx and NOx emissions, because that's even taxable in my home country, can you believe it? So one of our customers actually paid 26,000 euros for, in tax extra, for a 14-day trip in Norway with a super yacht due to SOx and NOx emissions. So that's kind of, and it turned out the calculation was wrong, so he paid too much. Anyway, so this is like, so there could be legislation drive, and then it could be community-driven by enthusiasts. There are people, marine enthusiasts, that could do some work. So it really depends on what service are we talking about. There will be different hosting mechanisms, maybe, but we can see the point. That's the problem.
Yeah, I mean, just to, to make clear, I think what Phil's point was is that, we're developing an open architecture, for a variety of very, very good reasons. One of the results of that open architecture is basically a large set of extremely valuable data. Who owns that data? Who controls that data? You want to make sure you don't get into a point where you're creating this large set of valuable data to create something which you are then going to be beholden to after a period of time. For example, I mean, you generate the data. I say, you know what? I'll take care of the data for you. I'm going to create my own little company called Jim Jag Co. I'll handle the data, and we'll be fine. I'll let you guys use it. And 5 years down the line, I say, you know what? I'm going to start charging you for the data now. Okay? Thank you for the data. I'm going to be charged. So that's, I think, was Phil's point, is that as this becomes more successful, as this becomes much more of a game changer for the maritime industry, you want to make sure that you create opportunities for new businesses, new startups to come up, but also make sure that there's sort of like a level playing field for all these new startup opportunities. And I think that was just the point. Right. And so, ideally it would be, a nonprofit entity that had, either, community, sponsorship or some other kind of sponsorship that was dedicated to the control and management of this data. And then, of course, that would mean that if you wanted to create a special company that used that data and add extra stuff to it, new features to it, that's fantastic, because that's where the value add is. There's a level playing field. What Phil would want to do with the data might be different from what I would want to do with the data. It would be different values, but it would be creating an opportunity not just for me to create a company that no one can compete with, but all of us could create companies using this valuable data set. And so that again shows how this can really spearhead and start a huge plethora of a huge collection of startups and companies based on technology that we're talking about implementing right here.
I think we're going through the list of Tony's how to make money with open source, right? On options of what you could do once it's there. I think the key question is to think about how that structure would look like and find sponsors for the first iteration of that, right? And the more official public that sponsor is, the better, right? So you talked about United Nations and their interest in pollution, right? Maybe that's a good hook. It would set it up from the beginning to be, you know.
And we're also thinking that it's something around, we're working on the key takeaways here, because I think that what we need and what MARSEC needs, because we're after all a small organization of enthusiasts and researchers, I think we need some kind of advisory board or advisory group from the open source community where we can kind of discuss various options and say, okay, this we have to keep open, this has to be for free, this has to be hosted by a neutral organization, whilst this service you can actually envisage that there's a market for and it doesn't compromise the overall idea, because that is very difficult to foresee in detail how that will evolve. There's another thing we have thought a lot about, and that is that there is an enormous amount of research going on around the next internet, an Internet of Things and so on, and we could with smart partners apply for funding in that area, because the beauty, again, as Jørgen has said beautifully a number of times, we have a very tangible but still not complicated market. We have 60,000 commercial vessels, which is nothing compared to many other markets. So, and they're pretty advanced, and we know a lot about them. So we can use these as research objects for various things, as long as the owners agree. And based on that research, we can make our conclusions. Okay, this goes into the open source. This can be handled if there's a market for the service. Some companies pick it up. But it's quite a complicated strategic job that requires quite a group of competency to really shepherd in the right direction, because there is a risk that we build some kind of data cemetery that cannot be untangled, because there is not commercial interest for it, there's no research funding for it, there's basically, so it dies away. So that's our concern, but I think we've learned a lot from you guys in the past few days. Would you like to bring up another topic before we have a break, Jørgen? No. Okay. Any questions from the floor around this?
Thank you. Actually, it's more a set of small comments from our side. Regarding open data, we have a very strong position that we want, especially in our e-government or public sector activities, push for open data. But not only as data as such, but really looking at the semantics behind, so we could speak more about standardization of information. Because then we are moving to the direction of having a platform where you can use it and you can also plug in, as long as we have the common architecture. So again, please think about what it means for these kind of services when we speak about open and standardized information instead of just open data. Because from our perspective, it means exactly the same as we did when we created the mobile phone industry. We started to speak about standardized communication. Now it's the time to really speak about standardized information. Secondly, when I was listening to what you spoke about fault tolerance, and I would say fault-free code, I think we are now in a certain collision between two software cultures. I'm a control engineer, having done quite a lot work with industrial automation systems. And of course, if you think about a power plant or paper producing plant, nuclear power plant, you need to have fault-tolerant redundant systems. Or if you have a paper producing plant, paper mill, a minute costs $500,000. So again, you are, I think, in the maritime sector now entering this world regarding reliability. We as customers, individual citizens, have been too tolerant to the poor quality of software. I wouldn't like to boot a system every now and then, and that is happening in mobile phones, iPads, well, you name it, in consumer products. we are not even close to the reliability I would expect from a system. So again, well, there would be a time for a riot from the customer's perspective, from the citizen's perspective on consumer-oriented software. And of course, as said, open source components, as they can be more openly tested, very often leads to better quality. And that's, for instance, one reason why we consider that open source is the only right approach to, well, virus and security software, because that can be really totally debugged by hackers, the most clever people in the world regarding software. Because then you have also prestige as driver, not only, I would say, the traditional software professionalism. And what is, I think, well, worthwhile when we are speaking about architectures in general, too much, to our taste, of the software has been designed from a vendor perspective. What are the offerings, rather than the user? That is what I tried also to touch in my presentation. We should look at service convergence around certain events or certain functionalities which, again, are putting the different vendors, the different kind of even technical components together, so that actually the systems architecture could be designed more on events-based things close to the user or the functionalities. Well, if I think about a vessel, it doesn't, well, the system doesn't need to work perfectly as long as all the functions of a vessel work perfectly. So again, looking at the functionalities as the basis for the architecture and combining the open source building blocks in that way might be leading more to natural fault tolerance systems than if you look at that from equipment perspective.
Yeah, we were approached in the open source lab by the OpenStreetMap project, and they want a trusted third party, neutral third party in North America. And we're just starting the hosting process of that. I was thinking I'll extend the same thing. If you have OpenSeasMap, go grab that domain and everything around it, because something similar, I think, to what Phil was talking about would be very, very interesting. Because the crowdsourcing that's been done on OpenStreetMap and the sort of the way the community's built, they were very excited to find someone that wanted to partner on that project. And I was thinking, you've got almost a parallel there on what you're trying to do. Could be very fun.
We are used to fault in the marine industry. I can tell you, I'm not that old, but when we were looking at the sun, it was cloud, not your cloud, ordinary cloud. So we couldn't find out where we were, and we couldn't see the stars. And even we had lines outside the boat to measure how far we were going, and the shark took that sometimes. So we are used with faults all the time. But anyhow, I have a question. I don't know if it's a vision or is it wish or if it's a dream. But if you can manage Google Earth in reality time, then you can take a big jump over everything else. So you can see what happens around you now with collision, because navigation is very easy. It's just to find Beirut or Malta or Grand Harbor. And the other thing is to make no collision during the voyage. And if you can have that in reality time, then you have all the results. And I understand this is naval language, CPA and TCPA as the closest point to approach to all other vessels. And I can also see when I go to Malta, and I can find out notice to mariners, but I also can check in at Facebook and get this information when I check in Malta Grand Harbor. On Saturday, you have to beware there's a Rolex adventure, so keep out of the sailing vessel. They will not act normally. So then you, I don't know if it's a wish or a vision, but just take a step over this fragmentaric area that Raytheon is a part of. He was talking a lot of open source. It's very close to us who use this. And of course, I want to share the depth. Then we get, if I share the depth all the time, then we will soon have a very good map because ships are everywhere. And I can share also if I see a container drifting on the sea. So I don't know if it's a question. Maybe is it possible? I should ask you from Google. And, yeah, we have went into a traveling sandbanks once.
This is a so the question about can we make Google Earth real time update the data underneath, right? That was, and maybe not Earth but maps. Is it possible? Sure, right? It's a question of how frequently do we get supply of. Let me start differently. The current system for maps is processing data feeds 24/7 and releases updates to maps about once a week. We have about 30,000 feeds right now of incoming updates from various groups who owns the data. We don't really own any data other than the overlay of the streetcars, right? So the real underlying map data comes in from the original owners who agreed to share that and make that available, and we keep in touch with them, and they have updates. Whenever they update, we get it fed, do some number crunching, cleanup of the data stream, etc., and feed it. And we do this on a weekly basis to update maps. Could we go from 30 to 300,000 a week? Maybe. The biggest problem we have is to find reliable partners for map data who actually want to share the data. Right? We went. I had about a 18-month little stint in Africa, where I was working with several official groups to get those maps improved on Google Maps. So there was paper maps around that we have a way to digitize and bring in. They had efforts they did some projects on water quality and improvement of water quality in their state. So they had very detailed information of rivers and whatever water carrying bodies they had. It was extremely. It took me 6 months to get them to agree to share that data. Right? Although you would, when you look at it, say it's a river, right? So that is number one, right? Find reliable partners who agree to share the data on a frequent basis, and then have those partners update that data, which is another hurdle, right? So updating, keeping these maps up to date is what we hear from them is extremely expensive. Right.
The users can update it as well.
Sorry?
The users can update
yeah,
it as
so
well.
that part, I don't know anyone who does this right now, right? So just the final one. What we do is now use all the base information to bring up maps as they are known, if you want, kind of as the base layer. And then we try to put layers on top of that we collect ourselves. Or there are some applications out that helps you track your bicycle tour on the weekend, right? So you have your mobile phone on, and it keeps collecting, and at some point you're able to upload, and you see where you've been on the map. But this is all kinds of on-the-top private data that you do whatever you want with. So from an infrastructure point of view, is it possible to increase that engine 10-fold, 100-fold? Possible. Maybe possible, right? I think the biggest problem is to find reliable data. Even the individual feeds, to get them to who says now this is the new reference, right?
This is a very interesting discussion, because I think this is where the marine sector has a is significantly different, because if we look at sort of the Google Maps or Google Earth domain, of course, if you talk about mid-Atlantic situations and so on, it's maybe a question how many data points you can get on a very high frequency. But if you talk about traffic, straits and harbors like the strait between Sicily and Malta, Gibraltar, English Channel, harbors like Grand Harbor, there are, first and foremost, there's an authority that takes responsibility and has a very significant interest in providing correct data. So they put out, as I said, notice to mariners, they take responsibility for the sea marks, and then there's another very reliable group, and that is commercial captains that take a great pride in not either goofing up or providing incorrect data. And as Jørgen says, if some hazards like floating containers, which is a very, very big problem in ship traffic, it's a nightmare for super yachts, because they can be very vulnerable if they run into, specifically if they have a fiberglass boat, it can be end of business very quickly. So that kind of thing, if we had an infrastructure to collect it and somebody willing and able to feed it back to the boat or make it available on the net or whatever, then it's problem solved. I think getting data in should be possible, but who is going to host it and who is going to, yeah.
You know, today, they have cars that beep when you get too close to a wall. They have cars that park themselves. They're not using maps to do any of that. They're using the data that they're generating and looking at that. So there are a lot of different ways for collision avoidance. You know, yes, one way is to have, you know, continuously updated maps. They're very, very good. There are other ways of just using data that you're, you know, you've got radar systems and depth sounders and stuff like that. So there are a lot of different ways of implementing that. We've got the, you know, you're generating the data. The problem is creating the software that collates that data and does what it needs to do. And again, that's the real reason that an open architecture makes sense, because, you know, even if software doesn't do that naturally for you, that means there's a market for someone to take the information that it's seeing in this open architecture and creating some sort of, you know, collision detection and avoidance software that plugs into that open architecture out there. So, you know, your question was, is it possible, to do some of this stuff? And, you know, the issue is just, is the data there? Once the data's there, then how much compute power do you have? And do you have an ability and the freedom and the flexibility to add software to the platform to, collect the data and generate some sort of response, you know, in response to that data?
I'd like to add a comment. AIS data is freely available, and there are actually overlays to Google Earth. There are websites online where you can actually just real-time see where all super yachts are that have the AIS system turned on, at least. Exactly, if they have it turned on, you can see it, and it even provides historical data. You can see where they've been, etc. So maybe it's not a question of data, but of metadata, adding stuff on top of what's already there.
That's one of the things with marine is you talk about collision with cars creating their own data and processing it so they don't hit something. That's great when you have brakes. But if you're not talking about hitting something like another boat that's sailing, but something that's underneath that's been disrupted by a storm or something, if you don't have that data that's been collected, great that your fathometer catches it 10 seconds before you hit it, you don't have brakes. Right. So it doesn't matter. So unless that information can be gathered and then disseminated appropriately among all the other ships that need it, whether it's by some chum overlay software or whatnot, then again, it is, I guess it's a lack of data, but it's not just AIS that's going to help you. So there's the extra dimension of it being maritime.
Sorry, I'm just going to add to that. You mentioned the containers. It's one of the biggest hazards, especially they're mostly submerged. And that is the question, is there going to be a sonar system that would be able to trace these things? I have had various talks with skippers in my past that they tell me they've run on an uncharted reef, for example. So this is the data that would be needed, required for these people, in my view.
Exactly. There's, I think we're kind of getting towards a conclusion here, because there are multiple opportunities that can also be commercially driven. One just by being in half of the world's marinas over the past 5 years, one typical thing that everybody mentions from the user perspective is this possibility to actually showing people on an electronic device where the free berths are. Because it's a very big challenge when a super yacht comes in at night and they scream on the VHF that it's this and that, and they don't really know where it is, and they have to send a bunch of guys out in dinghies and ribs to find the yacht and show them where to go. So commercially speaking, if we had the infrastructure of a map where we could actually make the two available berths blinking in some way, people would be willing to pay substantial money for that service. That could be the agents, that could be the marinas. So it's all about certain things people would like to have for free. Infrastructure questions and architecture and validity of data has to be sorted, but there's certainly a market, and the same goes for commercial shipping. Transport Malta and the traffic center here has a significant manual job of talking people into the right mooring and position for cruise liners, for whatever. So this can of course be automated, and there's a revenue generating possibility there. But I would rather like to see it as an app on top of something that exists than to try to solve that singular problem as a commercial, because it's too expensive if you solve it as a proprietary one-off system. Hmm? I guess it's time for a break. We have one more. One more question. Sorry.
Okay. Well, a lot of things have already been said. The grass is cut in front of me. But some experience I'd like to add. The discussion went into the direction of okay, nice to know what is on top of it, but there's also so much underneath, and there's so much more data. We had the experience, we're glad to help Alcatel with installing 2 fiber optic cables from Malta to Sicily. And if I look at the period in 2004 and then in 2006, and again next year we will see Nexans installing a power cable to Malta. What the difference was then, the big problems that they had getting updated maps and so on, and not only from the landing point, but throughout the whole Malta-Sicily channel. And the use of Google at the moment, and the ease of that, even if it is just for initial reference and then later checking with more official maps, but I think these two are growing together much more, and that is the realm where you're operating in. So that's a lifetime experience of underlining what you're saying, that there must be a market for it, because it is professionals that are using it, that need that data, and the faster that data, provided that it is reliable, is coming to them, the more cost effective, the more economic they can work.
Yes, what the gentleman referred to was the situation that the Malta-Sicily Strait is for professionals a very interesting area, because we pull cables through and so on. There was actually quite a bit of discussion of Google Maps underwater, kind of. How can you make a comment on that project? What's going on in that?
Unfortunately not. I don't know enough of what's happened. We put out, it's Google Ocean, yes, it's called, right? And it has attempted to do the same that we are more used to for the land part of the Earth, right, where we have the maps, to collect and provide the platform to surface all this. And they did. The initial round was quite successful in getting lots of maps in for there. But I don't know what's currently going on and what they're dealing with. No.
Okay, we know that the weather is about to collapse for tomorrow's middle sea race. They say it will be raining tomorrow. So I suggest we grab some drinks, we go out and enjoy the beautiful day in Malta. About half an hour's break, and then we'll have the last panel, which will be on front ends and ecosystems. So it's quite a mixed bag, but we have quite a number of things to talk about there, I think. So thank you very much.